Okay, in the second video, we're dealing with polynomials. So we did monomials. Polynomials are basically just addition and subtraction of monomials. So here's what we've got. So addition or subtraction of monomials. And then remember, the important thing to remember about monomials is that you have non-negative integer exponents. Okay, so any exponents that you're dealing with have to be non-negative and they have to be integers only, meaning no decimals, no fractions, whole numbers. Okay, so this example, we're going to be just determining whether each expression is a polynomial. So it's a yes or no. Then we can talk about the degree if it is. So here, this is actually a no. So here we've got just a normal expression. Its exponent is 4. That's an integer. And then here you've got a square root. There's no room for square roots in the definition of polynomials. So no. And then the reason to keep in mind is that you can't have any square roots. So square roots are not a non-negative integer exponent. They're kind of this other thing that we're going to categorize later, but just know for now that they are not integers. Okay. This next one, negative 16p to the 5th. Okay, that's a non-negative integer exponent. P squared, t to the 7th, 2 and 7. Neither one of them are negative. They're both integers. So yes, this is. And then what the degree is, I think you guys have done this before, it's the largest power. Okay, so this term right here has a power of 5. There are 5 p's. This term right here actually has a power of 9. There's 2 p's, 7 t's, which makes for 9 total variables in that term. Okay, so the degree of this one is 9. Okay, so again, we just get that by combining all of the total variables up. 2 here, 7 here, we just add those together. Okay, this next one, x squared, okay, the 2 works. Negative 3x to the negative first, that's a problem. There's a negative exponent right there. Okay, so the reason this was not a polynomial is because we had a negative exponent. Okay, so that's that first part, just learning to categorize them. Now we're going to work with them. We're going to add, subtract, multiply, and divide. So we're not going to divide, just the 3, addition, subtraction, and multiplication. So this one I'm going to show you guys 2 different methods. One method, we can kind of just leave it all horizontal like this, and we just combine up like terms. So we've got 2a cubed minus a cubed. So 2a cubed minus a cubed. All I'm going to do is just rewrite and kind of group them differently, and then we can simplify. 5a, positive 5a, minus, don't forget that minus in the middle, it works for all of them, and then negative 3a. And finally, a negative 7 on the left minus positive 2. Okay, so now we're just going to combine up all our like terms. So we've got like terms here, here, and here. We just want to clean those up. So 2a cubed minus a cubed leaves us with an a cubed. And then 5a, this turns into plus a positive, so that's an 8a. And then negative 7 minus 2 would be negative 9. So that would be your final answer. That's all you really have to do is combine up like terms. Be very, very, very careful anytime you're dealing with subtraction. You got to make sure you subtract every term. Okay, I'm going to show you an alternate method here. Some people work really well with kind of getting a nice visual of how these are being added together. So you can take both of these terms, write them in decreasing order, so highest powers first, and then plus, and just line the matching terms up right underneath, like that. Okay, and then the combining like terms is really easy because they're all lined up right on top of each other. So combine these up, and I would have a 2x squared. Combine these up for a negative 14x, and then combine these up for a negative 3. So 2 different methods, whichever one clicks with you, great, do that one. So is the set of polynomials closed under addition and subtraction? So what closure means? Closure means that if you add 2 polynomials together, what you get is still a polynomial. And closure under subtraction means if you subtract one polynomial from another, what you get is still a polynomial. So I added 2 together, this is definitely still a polynomial. And I subtracted, this is adding, and this is definitely still a polynomial. This is subtraction, this is definitely still a polynomial. So yes, absolutely. If I add or subtract 2 polynomials, the result that I get is still a polynomial. So that's what it means to be closed. Okay, so now this one, this is multiplication, but it's more like distribution. So we've got two types of multiplication. One is a little bit simpler where all you're doing is distributing one term, and then down here we're going to do the more complicated. Okay, so here, we're going to distribute that y to everything. So negative y times 4y squared. So the negative gets distributed. I know I have the 4, and then y times y squared. Remember, I add the powers. So I have a power of 1 plus a power of 2. So that gives me y cubed. Okay, then distribute the negative y here. I know it's going to be negative. I have the 2 from this term right here. And then y times y, I add the exponents together and I get y squared. And finally, negative y times negative 3. The negative times negative makes it a positive, and it's just 3 times y. So that would be your final answer. And now notice that is, again, still a polynomial. Okay, next, we got a little story problem here. Small online retailer says the cost associated with X units is given by this expression right here. So that's a cost expression. The revenue is given by this expression. Write a polynomial to represent the profits. Okay, so we've got this formula right here. That's like some econ stuff, I guess. So the profit is revenue minus cost. So we want to get the profit, and I'm going to write it in function notations. The P stands for product. So we take the revenue, which is given by 10x, and then minus the cost, which is given by this expression right here. So just like the one up above, since we're subtracting, be super, super careful. Make sure every term gets subtracted. So this equals, I've got 10x minus 5x, so that's 5x. And then nothing else combines with like terms, I'm just going to subtract it. So minus this term, and then minus 500. So make sure you are distributing that subtraction. So that is your profit expression. Okay, last thing we're doing is we're going to take products. So products are like foiling. You basically take each term over here and multiply it by each term over here. So start with a squared times a. So a squared times a is a cubed. Then a squared times 2, which is 2a squared. Then move to the next term, the 3a. 3a times a is 3a squared. 3a times 2 is 6a. And then finally, the negative 4. Negative 4 times a is negative 4a, and negative 4 times 2 is negative 8. Okay, so it's like foiling, but a little bit more extreme because we've got 3 terms over here. So now we're just going to combine all the like terms. The only a cubed is this first a cubed, so I got that. 2a squared, 3a squared, I add those together, I get 5a squared. Okay, so we got those. Now nothing's canceling, I'm just kind of keeping track of what I've written down so far. 6a minus 4a combines to a positive 2a, so I got those. And then minus 8 is my only constant. Okay, so I grabbed all my like terms, combined everything up, and that's what I get. Okay, for part B, I am going to set this up like I did in example 3b up above, kind of like a linear, vertical sort of thing. See if that works for you. So again, parts A and B, I'm just providing you with 2 different methods, whichever one clicks works. So this is like multiplying big numbers together. You start with this one. So you multiply negative 1 times 5, and you get negative 5. Then multiply negative 1 times negative 4x, and you get positive 4x. And then multiply negative 1 times 2x squared, and you get negative 2x squared. So I'm assuming that looks familiar, kind of from the way that you multiply 2 or 3 digit numbers together. And then, remember, you put a 0 as a placeholder here. And then we move to the 3x. So 3x times 5 is positive 15x. 3x times negative 4x is negative 12x squared. And 3x times 2x squared is 6x cubed. Oops, cubed. Sorry, it's a weird 3. Okay, so then we just combine them up vertically like this. So I get a 6x cubed. Add these up, and I get a negative 14x squared. And then add these up, 19x, and these, negative 5. Okay, so again, 2 different ways. Whatever clicks for you is totally fine. And last question, are polynomials closed under multiplication? So just like above, if I multiply 2 together, do I still get a polynomial? These are clearly still polynomials, so the answer is yes.